recording on this computer. All right. Balance brackets. What did y'all think of balance brackets? Liked it, disliked it, horrible, it's awful.
It's definitely good, but it was incredibly challenging for me.
Yep.
I liked it.
You liked it? Did anybody else? Did anybody was like, oh, that was easy? Does anybody like that?
No idea.
Yep. So balance brackets or balance parentheses. There's multiple versions of this same challenge. It's a very common challenge in interviews. So so it's a variation of this challenge is very common in interviews. So just whether it's balance parentheses or balance brackets, whether it's curly braces or like balanced whatever, like square brackets or multiple parentheses in addition to curly braces, as well as angle brackets and square brackets, all kinds of different variations of this same challenge. I think at one point we actually used to give a variation of this challenge for instructors for Code Platoon. I'm recording that now, so if anyone who ever wants to be an instructor at Code Platoon, that should memorize this challenge and you might be able to pass it. All right. So first things first, I'm going to go ahead and fork this over to my personal GitHub. So come up here, click fork. I'm going to go over to Tom Preet, and we'll do unit testing as well with this one. So I forked it over to Tom Preet's GitHub, forked over from Part-Time Charlie. Next, I'm going to clone that down by copying. You can either come up here and literally copy this link up in the URL, or just click this code, the green code button, and click that, and it copies it to the clipboard. Next, I'm going to go ahead and open up a new VS Code window. Where did it go? All right. It is getting kind of slow. All right. So open up a new VS Code window. I'm going to open the terminal and I'm going to navigate to whatever directory I want to clone this in. So I'm going to CD into my desktop, CP challenges. Let me zoom in a little bit. Is that good enough, or should I zoom in one more?
That's fine.
All right. So CP challenges, Charlie challenges, and I'm going to list everything out by typing ls. So I list everything out. I can see all the directories in here, and this is where I'm going to want to clone it. So I'm going to do right git clone and paste that link in there, paste it down, or paste it, list everything out again. And there you can see balance parentheses is there now. So I'm going to CD into balanced parentheses. So there we go. I can list everything out in there again. All right, let's see. Was there not a JavaScript and Python version, or was it just
Python?
Okay, cool. All right, so we've just got this README, and now I'm going to open this up into it. I'm going to reload VS Code where balance parentheses is in the Explorer. So I did code space -r space period. All right, so I've got that README. I don't really need that. I can always just refer to GitHub. But I'm going to make two files here. I'm going to make a spec file as well as just a balanced parentheses file where I'm actually going to write my algorithm. So I'm going to so I would create a new file. I'm going to say balanced underscore spec.py. And I'm going to also create just a balanced.py file. And list everything out in there again. You can see my balance.py and my balance spec.py. And I can open both of those up by doing code, just balance.py and balance spec, and it should open up both of those in my VS Code. So I'm going to split the windows here like so. So I have my spec file. This is where I'm going to write my unit testing or doing test-driven development. And over here in my balance.py file, this is where I'm going to actually write my algorithm. And if I open up the Explorer, you can see that I've got my balance parentheses right here. All right. What questions do you have about that process? Should be relatively familiar with navigating and get cloning, opening up VS Code and with and all of that. You should get kind of used to, you should be relatively used to that by now. All right.
Tom,
Yep.
so I'm noticing, and maybe this is just because we're a little bit still early on, but I'm noticing that you're pretty much doing everything within VS Code.
Yes.
I'm typically doing mine in iTerm, but I don't, obviously it doesn't really matter how we do it. I'm just wondering, is there stuff that we're going to be doing later on that will have to be using the terminal specifically?
So we are using the terminal down here, but I'm not using iTerm. That's just because I don't want to keep switching to different windows. Now, so I personally don't use iTerm anymore. I used to use it a lot, but now I'm just used to using everything in VS Code. So if you are using iTerm to navigate and do everything, that's totally okay. So just whatever process works for you, definitely continue doing that. So there might be, if you need to have like multiple servers running on your machine at the same time, you might want to have like your iTerm running a server just so you can see what's going on in the terminal, and then one in here. But you can have multiple terminals running at the same time inside of VS Code as well. But that's just, again, user preference. And we'll get to that way later on in the course, like running multiple, like having your backend server and your front end server. But yeah. So yeah, I just use everything in VS Code. Yeah, good question.
Thanks.
Anybody else have any other questions about any of that?
I had a question about unit testing versus the spec file. Is there a difference between, like, if you make a unit test, you have to label a test versus creating a spec file and calling it spec? Are they the same thing?
So like calling this a spec file versus calling it dash like test or anything?
Yeah, like a test file. So like, is there any difference between that, or do they basically
No,
mean the same thing?
they pretty much mean the same thing. It just depends on the architecture of how your application is architected, like or the naming of your, how you decide to name your files and everything. But generally speaking, I've seen it's spec. If you want to do a unit test, you generally name it a spec file using SPEC. That's just general naming. Best practices, I guess.
Okay, thank you.
Yep. All right. Yeah, any other questions? Nope. All right. So we did cover, you all covered the unit test library in Python on Saturday. Is that correct?
Yes.
Awesome. All right. So I'm going to be using the unit test library to write unit tests. But, you know, I'm a new developer. I'm not that familiar with the unit test library. It's actually been a long time since I've used it. So I'm going to have to read the documentation. So I can say unit test Python. I'm just going to do some Google search. It looks like I've visited this before at some point. And I'm just going down and looking at, you can read through the documentation. But what I want to do is look at some, like a basic example, and I see a basic example here. So it looks like the first thing I need to do is import the unit test module, unit test library inside of my spec file. And it looks like here we have a class. This should start to look familiar to you, this class, whatever. And then these methods with the self keyword, self.assert equal. And then we have this if name equals main, unit test main. I'm not quite sure what that means off the top of my head right now. But it's just something that we need to have in our file. So I'm going to pass it down like so. So I just pasted that over. And let's see. So we imported unit test. We have this class test string methods. We don't want to name that. We want to call it test balanced. What is it? Parentheses or something, or we can just say test balanced. Or we can just say like balanced test case. Whatever, we can kind of call this whatever we want, but the unit test naming should be related to whatever method we're testing. So I can just say like test balanced. Yeah, I'll just say test balanced. And we don't need to know about what this means right now, but I'll leave that here. We're actually going to kind of learn about what the syntax actually does. So I'm just going to look over at this code, and I can create some unit tests based off of what this input and expected output should be. You can do all of them. You can do a couple of them, but you don't have to. Whoa. I'm gonna delete. Looks like I have too many of those. All right. So one thing about the unit test library is that each test method or each unit test needs to start with the word test underscore, then whatever you're testing. So if you don't, they'll throw an error. So just keep that in mind when you're naming your methods for the unit tests. Just make sure that the very first word begins with test. So what are some things we want to test? So I can say, I'm actually going to look at what it should return. So write an algorithm that takes in a string and returns a string with a balanced parentheses only. So it needs to return a string. So I'm going to just test returns a string. So here, I'm just going to keep looking at some unit tests just to see what this looks like. If there's anything in here, you can look at like fail fast. You can like look at what some of these, what some of the stuff does, like the setup and tear down. But for right now, I'm just going to say, when you call balanced and you pass in a string of that first value, you should get a string back. So when I call balanced, I should get a string back. So I can say the type of balance, and I haven't written this method at all yet. I should get a string back. And I'm just going to comment these out initially. And I'm going to run this. So I can run Python balanced spec. It looks like it ran. Let's see what it says. You've got an error here. Test returns a string. When you call balance, you should get a string back. That's where it failed. It says name error, name balance is not defined. So balance is not defined. It doesn't know what that is. So over here in my balanced.py file, this is where I'm going to actually write my methods. So I'm going to type def balance. It's going to take in some string value, and I'm just going to return an empty string and see if this works. So now I need to import a balance from the balance.py file into my balanced spec file. So I can say from balanced. So from the balance.py file, import the balance method. I don't have to export this at all. I just can say from whatever file, import whatever method I want. So if I clear the terminal again and run that first unit test, one test ran. Right there, that means it's okay with that period, and it passed that test. what questions do you have about writing your first unit test in Python?
Tom, on line 8 of the spec file,
Yep.
when you're asserting equal between balance and then str, what is taking the value of str?
What's taking the value
Or
of str?
what is the value of str?
So the value of str is a string type. So if I say str, or not Python, if I do print str, I'll run that again. You can see it's a string class. So I want to make sure that my balanced method returns a string class, returns a string. So str is like short for string, int is for integer. I think it's like dict is for dictionary. Yeah. Does that help answer your question?
Yeah. So in this case, it's just checking between the result of balance being called, which in this case, it's an empty string,
Mhm.
and the type of string class. So,
Correct.
and they're technically both strings. So
Yep.
it will return true.
Correct. Yep. So this returns a string, and in Python, everything is an object or a class. This is this little value on line 2. This is actually a string class.
I've got a quick question about that. It seems like in JavaScript, if you'd call that with an empty string, it would return false. Is that correct? Isn't that don't empty strings in JavaScript return false?
Not if you want to return the type of whatever the type is.
Oh, okay.
So in JavaScript, if I were to have an empty string, yeah, technically an empty string could, wait, yeah, off the top of my head, I don't know. Does an empty string return to a falsy value?
I think so. I think it
Yeah.
does.
Okay. Yeah. So if it returns a falsy value, that doesn't mean it returns a Boolean value, which is false. It just means if you try to compare it, it's
Okay, that was
to a
like,
truth. Yeah.
so it's still a string type. It just has a
Yep.
return a value.
Yep. What other questions you have about that? All right, so let's just write a couple more unit tests. I'm going to create another unit test and said test returns. I don't really know what to call this one. I'll just say like a correct value. It returns the correct value. And I'm going to do a couple of these. So same thing, when you call the balance with that in, you should get, what should we get back? We should get just that back. Like something like that. So instead of a string, I should return, that empty, just like open bracket and or open parentheses, closing parentheses. I can do a couple more of those. So I'll do 2, and I'm just gonna copy some code over, just so when you call balance brackets or balance parentheses with that, we should get that back. And I'm just going to copy some more. So I'm going to replace these. Let's see. So I need to make sure my indentation is right. And this fourth one, I'm running like a bunch of tests in this last unit test. I'm testing 4 or 5 different inputs. So if I clear the terminal, run balance brackets or balanced up spec file, I can see So all these have failed at some point. These don't necessarily run in the same order. So notice how these failed, but you can kind of see which ones failed. Test returns the correct answer 4. And see where they failed. All right. So I've written several unit tests. Now I can go about trying to actually solve this. All right. What questions do you have about the different unit tests?
As far as naming convention goes, when you're naming your method tests, is that appropriate to call them method tests?
I think you can just call them unit tests, like unit tests. Yeah.
Okay, so whenever you're naming them, I kind of got in my own head about naming it, so I kind of just ran down the list and I just went like test 1, test 2, test 3, even though they were all kind of different. What issues? I know that that's not right. So what issues does that or could that bring in the future?
The only issue it could bring is that you don't necessarily know what that unit test is actually testing based on just the name of it. So it's okay to name it like a super long, like test should return. For this one, it's like seems like it's a little difficult to like think of naming what you should name these, because they're all like relatively like, how do I differentiate this test if I'm testing this input from this input? Like it's hard to differentiate the naming for that. But you should try to describe specifically what you're testing, such as like test should return a string. So yeah, so for this example, it's not that big of a deal if it's like their arbitrary test naming, but when you have when it's easier to differentiate what you're actually testing, then like actually name the test specifically what you are testing for. I don't know if that was helpful. Take your head out of that.
It was also, and maybe it's me also being lazy, but if you're already having like that string underneath that descriptor, would that really matter then? If I name the test 1 or 2 or whatever, and then I have a pretty good description of what it's supposed to do, would it matter?
Yeah, so best practices, you should name your method like very specifically to what you're testing. So if you were to ever submit code for review and you just named it test 1, test 2, test 3, your senior engineer would be like, no, name it different. I don't care what you name it, but don't name it that.
Tracking, thanks.
Like you can literally like call it like, I guess like you can, I guess, convert this into like an actual unit test, like test when, and like you can literally name it something similar to this, but then you get like, whoop. But yeah, like it's difficult to name these tests specifically for each unit test. All right, let's go ahead and try to solve this. So it's returning a string now, but that's obviously not the right answer. So let's actually look at some inputs. Let's just look at like this one. I'm going to bring that up top. So if this is the input string, this A parentheses B closing parentheses C followed by a closing parentheses, and I want them to be balanced, and it should just be A open parentheses B closing parentheses C without that last closing parentheses, because there's not something that matches that. There's not an opening parentheses that matches that closing parentheses. So how we can solve this is just match up each opening bracket or opening parentheses with a corresponding closing parentheses. This is where we use a data structure called a stack. I think we're going to talk about data structures a little bit later. But when you think of a stack, you can think of it like a stack of paper or a stack of pancakes. When you make pancakes, you put them on a plate, you stack them on top of one another, and then when you go to take them off, you take them off from the top. That's what a stack is. That's different than a queue, which is like when you're waiting in line at like Disney World, the first person in line will eventually be the first person to go out, get on the ride. So that's the difference between a stack and a queue. So what I'm going to do is loop through this input. And so I'm going to loop through this input. And I'm only going to check to find the parentheses, the opening parentheses and closing parentheses. So I'm going to loop through. I'm going to look at A. Is A an opening parentheses or closing parentheses? If it is an opening parentheses like it is, I'm going to push it to a stack. Actually, I'm going to push that index to a stack because I want to keep track of the indexes of the, I guess, the of like where all the parentheses lie. So I can create like a left. I'll just say a stack. I'll say open stack and a closing stack. And so when I get to this part, this opening parentheses, I'm going to push this index into the open stack. So which is going to be an array. So if this value is 1, I'll push it into 1. And then I keep looping through, and then I find a corresponding closing stack or closing parentheses. And if this open stack has a value in it, I can remove this index now. I can pop this index off. So it loops through, finds this open parentheses. All right, push that index to the open stack, like open side of the stack, keeps looping through, comes over here, finds the closing parentheses, and then checks to see if open stack has a value in it, if it has a length. If it does have a length, I can pop off that closing bracket or that index. And then I can come over here, find C. All right, now I come over here and I say, hey, there's a closing parentheses. Does open stack have a value in it? No, it doesn't. Now let's add that index to, is it 4, to the closing stack. So this means the value, or that's the character or whatever that exists at index 4, 0, 1, 2, 3, I guess it's index 5, is not good. So we don't want to include the value that exists at index 5 in our final string. And let's actually look at another, look at, where's one that's good? So like this one, I can do that same thing with that input. So if that's an input, I can loop through. All right, that's an open parentheses, push that into here, come over here. That's open parentheses, push that index in here, come over here. That's a closing parentheses. Okay, does this open stack have a value in it? All right, pop off the last value. All right, now come over here. We have an open parentheses. So that's index 3. Do we have a closing parentheses? So now we go to the next one. We have a closing parentheses. Does this open stack have a value? Yep. So let's pop that value off. Next, come over here. Let's pop that in is at 0, 1, 2, 3, 4, 5. So 0 and 5 are index, the values at 0 and 5 do not belong in the output string. So that output string, what should it return? Should just return that. So once I have these, once I have this bad stack, I would call it, I can then loop back through the string. And if this index exists, don't include it in my output. So if I loop through, all right, index 0, don't include it in my output, include this in my output, include this in my output, include this in my output string, include this in my output string. All right, index 5, don't include that. So my final index or my final output should just be that, these opening curly braces or open parentheses and closing parentheses. So if I actually wanted to code that up, let's see, I can say left, I don't want to call it left stack. Let's call it like open parentheses, Is that how you spell parentheses? I'm an idiot. So open parentheses stack. I'm gonna have it be in,
I think it's SIS.
what in the hell? And do we, well, I just copied that. I'm just gonna use that for right now. We have an open parentheses stack and we have a closing parentheses stack. So what I'm going to do is for the index in the range, so I'm using Python for the length of the input string. So I'm going to loop through the input string. And I can say, hey, if this value at whatever this index is, if it equals an open parentheses stack dot push, now that's JavaScript, append the index. So I'm going to keep track of the indexes of where of where all like the parentheses are. I'm trying to I'm trying to create an array of indexes of the bad parentheses that don't have an opening, closing, closing matching parentheses. So, all right. If the value at that equals this open parentheses, push it to this open parentheses stack. If it doesn't, I'll do else if the string equals a closing parentheses. Now, if it matches a closing parentheses, I want to check in the open stack, excuse me, and see if there's a value in there. And if there is a value in there, that means that's the matching parentheses. That's the matching closing parentheses. So I can check to see, hey, if the open parentheses has a length in there, so if there is a value in there, so if length of the open parentheses stack is, I guess, greater than or equal to 1, so it means there is a value in there, I can pop that off whatever values in this open parentheses stack. Else, that means if there isn't a value in this open parentheses stack, that means that there isn't a matching, this closing parentheses doesn't have a corresponding open parentheses. So this is a bad parentheses. So I want to keep track of where that index is. So I can say closing parentheses stack dot append the index. And then once I have those, the open parentheses and closing parentheses stack, both of these, whatever values are in here, equal the indexes of the bad values, the bad parentheses. So I can let's actually just print. So I'm actually going to combine these into one array or one list. So I'm going to call it bad stack equals open parentheses stack plus closing parentheses stack. So if I just printed the bad stack and I did this as an input. So let's just actually run this. Print balanced here. So this input should have a stack. So when I print the bad stack, it should have I should essentially print a list that has 0, 1, 2, 3, 4, 5. It should have a list with the number 5 in it because 5 should not exist. The value at index 5 should not exist in this string. So if I do Python balanced.py, there we go. So let's actually check a couple more. So if I wanted to do this one. So if this is the case, this is a good one. So 0 is bad. 0, 1, 2, 3 is bad. 4 is bad. So 0, 3, 4, 5, 6, 7, 8, 9. So this value should return a bad list of 0, 3, 4, and 9. Is that it? So if I cleared that and run that, 0, 3, 4, and 9 exists in this bad stack. So now that I have a list of indexes that shouldn't, indexes where the value should not be in the output, now I can just loop through that string, check it if that value, whatever value is at the index, and not include it in my answer. So I can say balanced string. This is my answer array, or I'm sorry, my answer string. I just say answer. And now, let's see. So I can check to see if that bad stack has a length. If it does, that means I need to remove some values from that string. So I can say, hey, if the length of the bad stack is greater than or equal to 1. Now I can say for index in the length, oh, sorry, range length of the string. So I'm looping through that string again. I can say, hey, if the index is not in the bad stack, so if that index is not in the bad stack, I want to add that value to the balanced string answer. So I can say balanced string answer plus equals string at that index, whatever values at that index. And then I can just return, after it loops through it, I can just return the balance answer string. Else return the string. So if I ran that, let's just check this value. And ideally, I can just run my balance spec file, but I just want to make sure that these work on this. So there's that first value. That's the expected output. Now I can check the other value. There, that's balanced. Now, hopefully I did everything right. And I can pass the spec file, all my unit tests, Python balanced spec, ran 5 tests, and they all passed. You can also run green, balance, that spec. Did we talk about green library at all?
No.
No. So green is just another library. So if you can pip install green, it just makes it a little more visual when you actually run your tests. So in order to install it, you just run pip install green. It's I already installed it. And instead of running Python balanced spec, I can run green balanced spec. That just gives it a little more visual. It's got some colors in it. It says ran 5 tests using 8 processes. Okay, passes 5 unit tests. That's all green does. What questions do you have about the logic of the balance parentheses challenge?
This isn't super specific to the problem itself, but I've heard recently that for loops are relatively inefficient. I was just curious if just looking at this, if there's any ways you would optimize it not using for loops.
I don't know if I'm sure there is a way to optimize. So for loops, it's okay to use a for loop. In most, I'd say, I don't know if there is a way to use this in a for loop. But like using a single for loop is totally fine. A lot of built-in methods use a single for loop. It's when you get into nested for loops is where things start to get inefficient and where you kind of want to avoid. So I'm not using any nested for loops here. I've got a separate for loop here, and then I have a separate for loop here. That's not a nested for loop. If I had a nested, it would be a for loop within a for loop. That's where things can get, that's where things you kind of want to try to avoid. There's probably a more optimal way to solve it. But again, first things first, try to get the answer and then go back and optimize. Yeah. So the answer is I don't know of a way to solve this without using a for loop.
Your clarification was perfect because I think it was in the context of nested for loops. So
Okay.
that makes sense.
Cool. All right. Any other questions? All right. So now I'm done. I'm going to add everything, get status. So I got this PyCache file. I can do get reset. I can run a git ignore, or I can just do get add balanced.py and balanced spec. Now I can do get status. So now I'm just adding these 2 files. I'm not adding this PyCache. And git commit. Oh, shenanigans. Whoops. I don't know what the hell that was about. Oh, I just committed it, whatever. Get status. Git push origin master. I accidentally committed it without having an actual message. It has I, that's not very descriptive, but I'm going to create a new pull request. Now I'm in part-time Charlie. I'm requesting to pull Tom Preen's balance parentheses into the part-time Charlie balance parentheses. I'm going to create a pull request. Instructor solution, and just create that pull request. So now if you want to go and just double check or try to attempt it yourself, and if you ever get stuck, you can reference the instructor solution or one of your fellow students' solutions.